Okay, so I want to look at this thing called the sandwich theorem. It's also called the squeeze theorem. I think it's also called the pinching theorem in some places. But sandwich and squeeze are what I've heard most of the time. So the wording I think is a little complicated looking, but it's actually a pretty simple idea. Let's say you've got this blue function here, and it's a totally messed up kind of function when you're trying to figure out a limit at this point right there. If you can find two functions like h and g, one that's always above and one that's always below, and they all meet at that point right there, they get squeezed in right there, then you can really just take the limit of h and the limit of g at that point, and you force f to have that same limit right there. So it gets squeezed into a specific spot. I actually think it's easier to do an example than it is to just kind of talk about it. So here's an example down here. We want to show that that limit ends up being 0. And so this is kind of a messed up function to plug 0 into. You can't plug 0 into that because sine of 1 over 0 isn't, there's a discontinuity there. And this one's the oscillating discontinuity for when you plug in 0 there. So you don't really know what happens to that just by looking at this directly. But what you can do is this. We know that sine 1 over x, all sine stuff is always going to be between 1 and negative 1. And x squared is a positive term, and if I just multiply everything here by a positive number by x squared, then these signs don't change. So I've taken this line and multiplied every term by a positive x squared, by positive number. Okay, so now if I take the limit as x goes to 0 of this side, I know that that's going to have to be in between, or this, let me just write it out rather than say it. Right? This should be true too. The limit should all be the same there because the middle function is always between the other two. So these limits on the end are easy to figure out. The limit on the left side is going to be 0. The limit on the right side is going to be 0. So if you think about it now, here, let me put these in brackets. If you think about it, if this limit in the middle has to be between 0 and 0, well, then it has to equal 0. And that's what that sandwich theorem says. Right? Therefore, this is true because of the sandwich theorem, or the squeeze theorem, whatever you want to call it. And there you go.